is this game right here, which builds strong number sense in my students. It's just which value is bigger. So what I'll do is for a week straight, I'll just give them 2 fractions, and then I'll give them a different type of example of this problem where maybe I'll have something being squared or cubed, or I'll use square roots or cube roots or any kind of operation that you want them practicing and getting familiar with over time. So we look at a problem like this and we're asked which value is bigger. Most kids would just go straight to a calculator, type 3 divided by 7, 4 divided by 9, and get those into decimals. But we want them to be able to use number sense and figure out which value is larger on their own without a calculator. So how would you go about a problem like this? We got to have a common denominator. So we need to make these 2 fractions into different fractions, but they have to have a matching denominator here on the bottom. So we got to ask ourselves, 7 and 9 can both turn into what number? That number is going to be 63. So we can turn each fraction into 60/3 by just multiplying each of those fractions by a value of 1. Now you might ask yourself, if I take this and I multiply it by 1, it's not going to make a 63 there, and you're absolutely right. So what's the trick we do? We write 1, but we write it as a special fraction. So we got to ask ourselves, 7 times what would make 63? The answer there is 9. But what fraction over 9, what number needs to be put over 9 to really make just 1? That's 9 over 9. 9 divided by 9 is 1. So really we're just making a 1 there. This is like unsimplifying this fraction. 7 times 9 makes 63. 9 times 3 makes 27. So this is 27/63. Now over here, we're going to do that same thing, but instead of multiplying by 9 over 9, because 9 times 9 would make 81, we need to think of what number times 9 makes 63. In this case, it's a 7. How do I make a fraction that's equal to 1 with a 7 on bottom? You put a 7 on top. So because we're multiplying by 1, it's not changing the value of the fraction, it's just changing the top and bottom numbers to larger values. Okay, so 9 times 7 makes a 63, 4 times 7 makes 28, and now that we have them written out like this with common denominators, it's clear 27/63 is going to be smaller than 28/63. So our answer here would be 4/9 is the larger fraction. And that's how you would do it without a calculator. All right, here we have 2 numbers, one given with a radical, one given with an exponent. So we need to check to make sure our students know how to simplify 2 to the 3rd power. Okay, that just means 2 times 2 times 2. So once they do this, they're going to know the actual value of 2 to the 3rd power. 2 times 2 is 4. 4 times 2 is 8. So this is really just an 8. And then the square root of 81, that means what number times itself equals 81. Remember, that number needs to be multiplied by itself. So what number times itself makes 81? That would be a 9 times a 9. So the square root of 81 is 9. So which value out of these is bigger? 9 is greater than 8. So you'd be saying the square root of 81 is the larger value between these two. Let's look at another example. In this problem, we're checking to see if they can compare a decimal to a percentage. They're going to need to know how to convert a percentage into a decimal. And all you got to do is just move that decimal back 2 place values. So that's going to end up giving us 0.057. Most students, if they can see those values like this, will know the larger of the 2 values is 3/10. Hopefully this makes sense. Study hard and good luck on your upcoming test.